what I was mentioning, for the calling sequence, that is basically referred to as the the allocation of the activation record, which is stored in the stack. So calling sequence basically refers to which portion of the record goes to which part and like which comes after which. So if this is the first portion, this is the second portion, this is the third portion, what is the sequence? How this calling sequence occurs so that they are stored sequentially. That's one thing. This is calling sequence. Another is return sequence. Return sequence. Now, what is return sequence? Return sequence is basically in what manner do we restore, or basically in what manner we pop the information from the stack and go back to the previous state. That is basically return sequence. So this is happening one after another. Now, for the calling sequence, the actual structure or the layout of the activation record may actually differentiate or differ because of a variety of implementation, because of the programming language, because not all languages work in the same way. How C works isn't how Java works, or how Python works isn't how Java and C works. Like that's one of the things. Now, in the usual case, the sequence, the instruction for the calling procedure. So this is the calling inside the calling sequence. We have now, let's say, the calling procedure. Calling of procedure, there are two things. One is the caller, another is the callee. The caller is basically the function from which another function is being called, and the call is basically the function which is being called. So from main function, we are calling, let's say, quicksort. So this is the caller and this is the callee. And for the quicksort, this is the function which is being called by some other function. So this is sort of a cyclic pattern. Now, for the sequence to maintain how this actually works. Now, in order to design the calling sequence, the layout of the activation record basically follows certain principles. So what are the principles? The first one being is for example, let's draw the diagram at first, which will make things easier. So the first thing is the items or the values which are like values required to communicate between the caller and callee are stored at the very beginning. This is one of the principles. So at the very beginning, we will store the information which will be required for the caller and the callee both in order to communicate with each other. Now, in order to make this possible, we know information is stored in what? Chunks of records, isn't it? Now, if this is initially stored so that caller and callee be able to use this, that means what? Using this values or storing these values into which record will make this more sense. For example, this is the record for, let's say, the callee. This is the record for caller, and this is the record for callee. The information stored in callee won't be accessible from the caller, isn't it? However, the information stored in the caller will be accessible from callee. Now, in order to make this value to be accessible from both of this caller and callee, Which one do you think makes more sense? Obviously the caller, isn't it? Hence, these values will be stored onto the record of the caller initially, which will be able, which the callee will be able to what? Will be able to access. Now, how do the callee is able to access this? Using the access link. Remember the access link we just studied? So the access link. Hence, this access link actually stores the reference to this record so that we could reutilize that record from the callee. Now, the main motivation is basically with the parameters, as I mentioned, the original parameters. Now, why is it so? Now, if you see inside this main function over here, where did it go? So inside this main function, we have what? We're calling this quicksort 1, 9. This 1, 9 is being passed from where? From this main function. So far, this quicksort has not yet received this 1, 9. Rather, this 1, 9 is being passed from this main function. Hence, this value is it is needed to be calculated within the caller's scope. Hence, the record of the caller, the record of the caller. And once the callee gets executed into its region, then once we are inside this, entering this region, already entered, then we have already shifted the value of 1, 9 into this region. That is why we require the combined or initial position to be to store the information basically of the parameters. That's the basic or the main part. For other portion, it for other things it could also be done, but the main point or main objective is basically to store or calculate the parameters in such regions so that both caller and callee are able to access them. And the second thing is, when we are calling a function, let's say a function is being called, the function always do not have the idea that how many parameters it will have. For example, the C's printf function. If you have noticed, this printf function can have multiple parameters. So if we have string %d, 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 let's say 4 %d's we have, then we will pass simply 4 values. So A, B, C, D. 4 values will be, 4 parameters will be passed. So in total, what? This is 1 parameter, and there we have 5 parameters. Now we have, let's say, thousands of D inside. Then we would have placed thousands of integer values one after another inside this printf function. Hence, when we are calling, let's say, from this main function, this printf function, we actually have no idea from this printf or the callee how many parameters will I be holding. The information only is known by the main function and hence propagated using the access link to the callee, which is the printf function. Okay. So it sort of allows us to not always take the same number of arguments, rather different arguments as well. At the same time, the final thing is basically, it also helps the callee, basically the function which has been called, to know the return value which is related to the activation record. Now, the activation record is basically, if we consider this activation record, then if we have the relative value, the return value, this is basically what? An offset set to this activation record, isn't it? With some offset, we get to store this return. So if you follow here, wait, where did it go? Over here. After the actual parameter, after certain offset value, there's immediately after that the return value. So if we have the return value, we know from this caller function, from the called function, where should we return back? Okay, so this is basically a sequential concept. Now after that, we have a fixed length item, which are generally placed inside the middle portion. So this control link and access link, these are sort of basically fixed length items. Now, this such items are basically, as I mentioned, is inside this access link and the control link. However, it is also inside this machine status. Why? Because if you focus, when we are storing the machine status, machine will have a consistent thing, isn't it? It will have, if certain architecture is followed, it will have the 64, let's say 64-bit registers. Then we have 64 such registers. Then we have the like 1 byte for, or 1 register for the flag register, and some other important information. And these are fixed, isn't it? The size of the register and the width of the register box, like all of them are fixed. Hence what? They are of fixed length. Similarly, the control link, that means the address or the reference is also of same length. The access link is also of same length. So these informations are basically stored inside the middle portion. And these are also sort of like included onto the color part. Now, why is it so? We will be like getting into that within a like few moments. We will be drawing a or sketching a diagram which will make it more sort of feasible to understand. The second, the next thing is basically the items whose size may not be known earlier. So that means dynamic size. Dynamic size. Those are basically placed inside the activation record of call E, because we don't have the information previously. So for example, the dynamic array size. In case of dynamic array size, we do not know previously from like prior, like what will be the size of this array. Only during the runtime, we will be able to know the length of this array, isn't it? If that's the case, once we are inside this call E, we can calculate the dynamic array and we can store the information. That means whatever is here, if you see up until this portion, before the call is activation part, activation record, this portion is basically fixed now, isn't it? We cannot change this portion, which we have just stored up until the access link, the control link, the parameter, and the return type. Like these are already stored here. We cannot change or modify the length. Those are fixed now. However, the portion or activation record of this callee, this is the present record. Hence, if we get some new dynamically stored value or calculated value from the user at the runtime, this could be what? This could be placed inside this activation record of the called function. It makes it more useful because now it can extend, and like this record could be extended further, like to the bottom, like to the bottom or the top of the stack. And this also makes more sense while generating the code. For example, the temporary registers or the temporary variables. If the registers have been finished completed, like we have used all the registers, then we increment the temporary variables. So for example, T0, T1, and T2. And we do not know how many T's we are going to, like we'll be requiring until and unless what? Until and unless we are executing the instructions. So that means until we go to the runtime portion, we won't be able to know how many temporary registers are going to be required. Hence, this temporary registers information will be basically onto the record of what the callee. Now, we obviously must know the top of the stack in certain manner. Now, the common approach is basically the end of the fixed length of the field of the activation record. Now, how this works? So for example, let's say example could be, wait, why is it taking me there? Yeah. So basically, let's say this is the stack, and here we have the params and returned values. Then we have, let's say, the control link, where the link of the safe status are placed. Then we have, let's say, this is for, let's say, the caller function for the which is calling. Okay, this control link, there is this access link. Like after this, there's the access link, and after that there were this temporary variables and data. So temporaries, variables, and data. And after that, we have, while we are calling now a new function, we have this parameter and return. This is from, let's say, this is for the main, from the main function to a quicksort function call. Then after that, we have the control link, which links to the safe status. And then we have the temporaries and local data inside the callee. Now, up until this portion, this is basically within the caller. Now, why is it so? Because the parameter and return values are to be recognized by the caller. It is so far guaranteed. It's fine. Now, the control link, if we talk about the control link, this control link has like this reference has to be placed by the caller, isn't it? Until and unless the caller sets the control link, because let's say there are some, as I mentioned, a which is used inside this call function. If a is a variable, then in order to access that, we must have from this callee's record, we must have the reference beforehand. So even before even before calling this function, we can, if we want to control if we want to store this control link or create this control link, who can generate this control link then? The caller only, isn't it? So the caller will be responsible for generating this control link. And once this control link has been established, then we can pass this control to the callee, basically the call function. And it goes on. Now, up until this much, it is basically stored in the controller's record. So this is basically the actual part is this controller's record. So control caller, or basically caller's record. And this bottom part is basically the callee's record. Now, if you notice one thing, if this is the callee's record, however, this like half of the portion of the callee's record is being operated by whom? The caller. This is the permission, or this is the access or responsibility which the caller has. So if this is the responsibility up until which the caller has, that means half of the portion of the stack is basically who has the control, or who has the permission, or who has the upper hand? The caller. And after that, the access or the control is passed to the callee or the called function. Now, if that's the case, the caller, basically what happens here, as I mentioned earlier, caller basically evaluates the actual parameters in this case, and then the caller stores the return addresses. So here the return addresses are stored. So if let's say for main function, if from third line we are calling this quicksort, so once we return the value, onto which next instruction should the pointer be placed? That's what return value is like storing, or what value is stored here as return address, basically. Then we have, we simply do what? We simply increment the, let's say this is the pointer, the top of the stack pointer. We simply increment this top stack pointer by some value so that we go to the next possible location. There we simply do what? We simply place the controller link. Again, we increment the top stack pointer value. So increment the top stack pointer value. And we are now onto the temporary and local data regions. So now the callee do what? The callee simply stores the registered value, the temporary values, also let's say some local variables which are declared inside, let's say int I, or those sort of things which the callee will be utilizing. Those values will be stored into this region. Now, this is basically what? A calling sequence. Now, the portion where we will a viable solution or viable place of return sequence is basically the callee places the return value next to the parameters. So here, this is what? This complete thing was the record of the callee, isn't it? That means if parameter is accessible by both caller and callee, this return value is also accessible by both caller and callee. So the callee now will place the return value to this, beside this parameter. That's the first thing. Then using the information of the control link. So inside this control link, there is actual control link, the access link, and the machine status. So using the actual machine status, it can restore the stack pointer and the register values, isn't it? So that it can go to which branch after the return address or return value has been made. So let's say the quick sort. So let's go above. So let's say the quick sort is now returning back. So here, let's say the quick sort is returning back. So return statement is the return 0, let's say. So once return is made, to which position, to which address should we return and what value to return? So, and to which region of the stack pointer to go to. So once we are here, we want, like, once this called function is popped, we do not want this region to be anymore here, isn't it? We want the next stack pointer to be at this point. So that means the stack pointer is also stored. The stack pointer is also stored within this portion, the machine status. So we have to restore the values. This is one of the sequence of what? The return sequence. So at first what? At first we place the return value, then we restore the status of the stack pointer, the other register values, and finally we do what? Decrement the stack value. We decrement the stack value to the next possible location where the previous record has been stored. Okay, this is how the return sequence work. So that's basically the calling sequence, which we just saw, where the before making a call to the before like making a call to the call for to making a call function, like making simply calling a function, which procedure to perform, and while returning from that call function, what sequence to maintain. So there is this calling sequence onto the same stack, and there is this return sequence onto this same like stack. This is how calling and returning sequence actually works. So basically, you have to have this concept clear. If you go through the section onto the book, section 7.1, most probably, let me check once more whether this is section 7.1 or not. Sorry, 7.2. So if you go through section 7.2, not 7.1, 7.2, so 7.2 completely, you'll be able to understand whatever I have said, like propagated or informed here. That's basically a gist of how this stack is being used in order to parse information. Now, if you see here, if you see or notice one thing here, we sort of generated this tree, isn't it? By hand, to simulate. However, while executing it in the machine, you have noticed we didn't require this tree, isn't it? This is basically to understand, to like generate the intuition. However, this intuition was basically built up, isn't it? This is, let's say, the caller function, and into that caller function we have this callee function. That means this is stored into stack. Then we have this record, and from that record we get this p is record, and once this p is popped, this q is being stored onto the stack, q's record. Then after that q, we store the record for p, and once p gets executed, the like we and leaves the p and gets back, we go to this queue, and from that queue we again call this queue, and there we set the parameters, the access link, the control link, and stores the machine status. And if you have noticed, while parsing these nodes or making these function calls, procedure calls, we're actually intuitively behind the scenario actually building up this tree, isn't it? This tree is actually being generated. Hence, we do not require this tree to be generated separately in order to like perform this expression or perform this operation. Rather, while working with this stack, this tree is basically getting formed or being generated by its own. So that's all for today. And that's basically the syllabus for 2025 summer semester compiler course. So we are officially done with the compiler course. And in the next class, we will be having a quiz, like sort of short quiz. Inshallah, it will be easy. And I will try to incorporate some of the concept from here. So basically, maybe some theory part, like how the tree is formed or how activation records are stored. I'll give that sort of thing. And we'll be maybe doing some examples regarding the concept of records in the next class. So till then, if you any question from so far we have covered. Sadman, any like question from this part? If not, then try to go through the. Sorry, lecture 20 won't be covered. That is eliminated. The heap we won't be able to, like, we won't get any more time to actually solve that. So hence, up until stack, which is up until lecture 19, that's basically included. Okay, so if you have any queries, then go through the lecture, the content, go through the recording, and consult me with like during my consultation hour. Inshallah, you will be able to get the gist. Okay, if that's like no more question, then